Dr. Subhas Sikdar, Editor-in-Chief, Clean Technology and Environment Policy, USA. May I request him to deliver his speech on assessing technological advancement for sustainable.
Thank you very much. I apologize for the initial special arrangement that had to be made for me. I wouldn't go into the reasons. You might ask the organizers later on. But this may be, in fact, good for the following presenters who may take advantage of this special arrangement. Good for older folks like us. All of you have heard of sustainability, sustainable development. These monikers and terms have been in widespread use for several decades now. And to make it worthwhile for sustainability discussion, it is important to know what it is we are talking about and how can we assure ourselves that we are in good state in terms of sustainability. Whatever you understand about sustainability, it doesn't matter, but the question that I like to address is there a way to assess whether we are moving towards sustainability or sustainable state or receding from it? That way we would know what needs to be done, what needs to be avoided, that sort of thing. That is essentially the main focus of this presentation. Sustainability became extremely popular, especially after NASA published this particular picture of the Earth from the moon. It's called Earthscape, and this is the first time we came to know the value of what we have in Earth. Earth as a treasure was vividly and philosophically revealed to all the citizens of the world who wanted to preserve what we have, this beautiful blue planet. And then sustainability became quite relevant as a point of discussion. But I want to focus on assessing whether we can tell whether our journey is towards sustainability or away from it. Anytime you want to do assessment, you have to test a hypothesis or test a claim and establish that claim with evidences. This is how we do science. And three things are important here. How we look at sustainability, a special look at what are relevant in terms of sustainability concept, then how we measure, if there is a way to measure it, and then how can we model this so that we can make some predictions about the future. Ultimately, that is the name of the game, because everybody in the business of sustainability has been making predictions of all kinds. And as Niels Bohr once said, predicting is difficult, especially the future. So first of all, let's look at how we look at sustainability. You will not be surprised to know that there are as many definitions and ideas of sustainability as there are people in the audience. And it depends on where you come from. If you are, for instance, an economist or a social scientist, you'll have one way of looking at it, the equality of opportunity, equality of well-being, etc. Nobel Prizes are given now on quality of wealth and that sort of well-being measure. Ecologist looks at carrying capacity of the earth. How much can we support and how much can we not support? A physicist takes a look at entropy or negentropy as it's called, reversing. Entropy is going downhill, so how can you go uphill, etc. And as chemists and engineers, we are more practical people. We have to do things with materials, and therefore we look at material design, process design, product use, reuse, redesign, that sort of thing. Those are practical ideas. And for social scientists, equality becomes a very much important thing. Therefore, there is really no clear way of integrating all of these floating ideas into one definition of sustainability. So it's much like blind men describing an elephant. You know the lore, but this has been chronicled in a poem by the American poet John Sachs, and this can be expressed as, and so these men of Hindustan is India actually, disputed loud and long, each in his own opinion, exceeding stiff and strong, though each was partly in the right, all were in the wrong. So in other words, if you look at a particular part of the elephant, and you'd be describing it in some fashions, you'd be right. You have a hypothesis, you have evidence, and you come to a conclusion. But you're looking at a partial picture than the overall picture. Therefore, overall, your description would be totally wrong, even though you are partially right. So, how should we, given the situation that we don't know what we are talking about, how can we salvage this mess? And one way that was promoted by some people based on the so-called Brundtland Commission, and in the Brundtland Commission, the synthesis was there are three things that we have to deal with. One is environment, the other is social, and the third is economic. These are three domains that dominate or determine our life. And this can be depicted as three concentric circles or ellipses. And if you do that, where they interact, if we can improve the economic condition, environmental condition, and social conditions of people, then we are essentially improving the sustainability condition. Therefore, the interaction of the three domains is where sustainability occurs. And I would only say that much. Therefore, the discussion has for decades been happening in terms of the interplay of these three domains: environment, the economy, and social. Now, where does technology, engineering, and science fit? They fit in the economic part because this is where wealth is created, and wealth is always created by ideas, by converting to practice some technical ideas. So these are three domains, but they are not independent of each other. You know, in mathematics or even in engineering, we like to describe things in terms of factors, and we like them to be independent of each other. It's so-called orthogonality. But these are not orthogonal domains. They are self-interacting. And very easily you can test this idea. If you damage the environment, you damage the social conditions, and you have economic consequences of the damage. Therefore, any change in any one of the domains actually affects all other domains. In that sense, they are not independent. But this is shown in this particular figure. We have three different areas here: economy, society, and environment. What happens typically is that we take from the environment resources for building economic capital, which then benefits society. And in doing this, we create waste, which is fed back to the environment. Sometimes we recycle, reuse, that sort of thing. Therefore, they're already integrated in the three domains in some fashion. But we have come a long way in terms of improving the conditions of the environment. Since I would say, actually before, but a good reference point would be the foundation of the Environmental Protection Agency in the US in 1971. There are other countries followed suit, but since US being a country of laws, EPA as constituted had a tremendous amount of power, legal power, to take people to court and fine them. All of this outside of a direct involvement of the Justice Department. But this did not happen, the improvement that I'm referring to, because remember, you haven't been present when the Alkali Act was enacted in England. They had LeBlanc process for making alkali, and this LeBlanc process, which is very interesting history, I wouldn't go into that, but actually it used hydrochloric acid. No, not used. It produced hydrochloric acid as well as sodium carbonate. That HCl was going into the air and eating up people's teeth. People were losing teeth. This is in London and in Ireland. So people got fed up with this situation, and there was a mass movement, and the parliament was forced, the inflection on the forced to enact Alkali Act. This was in the mid-19th century. Since then, we have made tremendous progress. Nothing like what I just described happens anywhere in the world. So that improvement did not happen because industry was generous, was kind, and was considerate. Nothing like that. Industry is there to make money, but the societal conditions determine how industry looks at things, and that, of course, has been improving as well. The point of fact is that EPA, Environmental Protection Agency, has been promulgating acts that US Congress passed, and there have been a plethora of these over the years, and that should be primarily credited for the cleaning up of the environment in the US. Not that industry automatically is evil, I'm not saying that at all. Profit motive many times forces industries or encourages industries to go in the right direction. For instance, steel. If you look at the history of steel making all the way to current tool steel, alloy steels, etc., you will see that the fuels that have been used and the processes that have been used to making iron and steel have made major improvements, not because government regulations forced them to do it, but because they found avoiding pollution is good for business, because you don't have to deal with waste as well as the downside of polluting the environment. Now, currently, this practice of environment and its improvement has been improving as the sustainability ideas are coming into the fore or getting into practice. One idea that has recently been very popular is dematerialization. Now, you might think dematerialization is getting rid of the material. No, that's not what it means. It means simply, technically it means GDP. I'm plotting GDP and time, with time. GDP has a tendency to go up. Let us say, schematically, this is how it goes, and environmental impact also grows, typically. And when the environmental impact grows slower, there's a slope being slower than the GDP, then we call it partial decoupling. When we can decelerate environmental impacts compared to GDP, this slope is negative, this slope is positive, this is called complete decoupling. That's what it means. It means using less for more. That's what it means. There is another idea which is important, environmental Kuznets curve. Kuznets curve means if you again look at environmental degradation and plot it against per capita income, which is a measure of GDP, you will see that as countries prosper in wealth, they pollute more and more. So this is the environmental damage. Environmental damage increases as our income increases. But this is not really what is happening everywhere. There is a tipping point beyond which further increase in capital per capita income will actually decrease the environmental damage. This is called environmental Kuznets curve. This is actually happening in most developed nations. Even in China, which current measures show that as they have become actually a first world country in terms of wealth per capita, they are able to more and more enforce environmental standards and put in more funding for environmental projects and measures, and therefore they're seeing, at least in numerical measures, some improvement. In the US, for instance, this picture I got from a book that was just published in 2019 by Andrew McAfee, More from Less. In the US, he claims dematerialization is actually happening since 2000. And all of these aluminum, nickel, copper, steel, gold, fertilizer, stone, cement, total energy consumption, even CO2 emissions, they have all been plummeting as GDP has been growing up. I have seen that similar data from the US EPA also. CO2 emission is particularly important. In 2019, the data came out last week. 2019, US emission reduction has been greater. 2019 has been an exploding year for the US in terms of economic growth, as seen by the stock market rise, etc. CO2 emissions reductions from the US in 2019 has been greater than all the developing countries' emissions combined. This is, I'm talking about all of Europe, Japan, South Korea. This is amazing. When the economy takes off like a rocket, this is dematerialization happening. Story is similar in most developed countries. So what is possible and likely versus failure of the nerve Sometimes people make predictions, as I referred to Niels Bohr, difficult predictions. I just was thinking of one prediction that I remembered last night. There is a book called 2081 by an astrophysics from Cornell. His name is Gerard O'Neill. He predicted that by 2081, which is many years from now, electric cars would not be profitable or operational, because he said it's a pipe dream, it will never happen. This is 2020 and electric cars are already operational. They are successful. There are many, many companies that are already making them and making profits. And Tesla, has been a pioneer in this area. Arthur Clarke used to call this failure of the nerve. People make predictions that they cannot prove by evidence. Even Thomas Edison used to say that AC will amount to nothing. AC means alternating current. So this was a spat with Tesla, or how wrong he was. So there have been predictions made by Malthus, Jevons. Paul Ehrlich is a good example. He wrote that beautiful book called Population Bomb, which starts with a description of the crowd in Delhi. And he predicted by mid-1980s, there will be hundreds of millions of people dying out of starvation, because, like Malthus, he did not believe that there would be enough food available for everybody. Now, we have more than 7 billion people in the world, and nobody I know is dying out of starvation. Then limits to growth. This is the MIT group that wrote this limits to growth. And Al Gore and his buddies were talking about 21-foot surge and Florida underwater. All of those were supposed to happen more than a decade ago. None of that happened. So this is the failure of the nerve I am referring to. Therefore, one has to be careful about what one does. Going back to this idea of sustainability, the major factor, as I was trying to build the case, is the environment. Rest is essentially secondary, because once the environmental ills are taken care of by economic means, which is basically the driver, then societal benefits accrue, not automatically, but does. So how do we analyze this thing? There are three things that we have to consider. Concept, what are the technical concepts we have used so far in promoting sustainability? What kind of measurements have we made to make our case? And what kind of modeling and design ideas we have in mind, so that we can make predictions, we can take this forward and make a scientific and engineering discipline. Traditionally, we started with waste minimization in the 80s, went to pollution prevention, then design for environment, industrial ecology. Finally, we ended up in sustainable development. All of these were building on top of another. It wasn't that sustainability came from God like manna from heaven. It wasn't like that. It was an incremental kind of thing. Therefore, it will be a mistake to think sustainable development is essentially devoid of all these previous concepts that led up to sustainable development. Other ideas under sustainable development have been industrial ecology. There was a demonstration in Kalundborg, Denmark, where they tried to connect all of these localized industries to make it so that there are no wastes. That particular scenario was replicated in Mexico, in the US, and still around in some form, but there are obvious difficulties in making it happen, and any one of you can think of impediments. Then there is this new fashion of describing essentially the same thing, circular economy. It started in Europe and it's trickling down to the US right now, as most of these advanced environmental and societal ideas originate in Europe and finally end up in the US, and we have to deal with them. Circular economy, essentially no waste society, as if there is no second law of thermodynamics. Life cycle assessment is an idea that essentially is the basis of confirming some of the claims that I wanted to contest. Life cycle assessment says that if we have a product like this, where it came from, all the previous steps that ended up in this particular bottle have contributed to the environment in some fashion and has had societal impacts and economic impacts. All of those would have to be integrated per some normalized by some kind of a unit like one bottle, and then expressed in environmental terms. That's called life cycle assessment. There are environmental life cycle assessment, ecological life cycle assessment, and cost life cycle assessments. All of those are being used, but they are always done in support of how we measure sustainability. Now, typically, how do we measure sustainability? We come up with, to take a very basic example of a comparison between some diesel manufacturer from waste plastic oil, polystyrene based, and let's see, what are we talking about? Oil from waste thermoplastics. There are two different examples here, and there are this is the reference point of diesel, and polystyrene and polyethylene are essentially the same polyolefinics, and they can be pyrolyzed to give you some kind of bio oil, and that bio oil resembles diesel, which can be used in cars. So how do we know that we are making progress towards sustainability, or how can we measure the efficacy of a process in terms of sustainability? We need a list of things that we want to use to do some measurement. And one can be property, specific gravity, calorific value, kinematic viscosity, C10 number, flash point, fire point. They measure certain aspects of the performance of the oil, and these are the numbers for two different plastics, and these are the number for diesel. And as this particular paper shows, that there is a good match. Now, not considering anything else, so far, technically they are equivalent. So this is one way people measure. Another way of measuring is through what is known as indicators. Indicators of sustainability or indicators of environmental damage. They're very precise, and there are measures available. So one example is an automotive fender by a German company, also called spider diagram, this presentation, using environmental indicators. And all of these are environmental indicators. We don't need to know what they are, but there are 12 of these, and there are 5 candidates here for this fender. They wanted to replace steel fender with aluminum and some plastic composites. Aluminum, steel was the original one, aluminum was one, then polycarbonate PBT, polypropylene EPDM, polyphenylene oxide, polyacrylonitrile. So those are the candidates, these are the properties, and this is called a spider diagram, where some they are normalized to 0 to 10 or something like that, and then you plot all the data that you have on the spider diagram for each of these candidates. And this is what it looks, and it's very difficult to tell by looking at the plot which one is better, which one is worse. But if you look carefully, you might be able to gain an idea of the best one. But a simpler example would be to look at this example, BASF, called eco-efficiency analysis. Here again, they have 6 indicators that they measure for 2 different products. Let us say one is indicated by the blue, the other one with red. So, energy, emissions, raw material, these are all important to you, right? But when the data on a spider plot look like this, between 2 candidates, you'll be hard put to it to decide which one essentially is superior. You cannot, because you don't know what is more important to you. If energy use is the most important thing, you would choose the blue one because that has the lower energy use. But then this also has higher emissions. So this is difficult. This was the original BASF idea, and then they found out that this particular one depicted like this. So if you put the alternatives here, you want to go this way. Environmental impact versus total cost. Because cost was not one of the indicators, so cost was presented in this particular fashion after aggregating all of these numbers in some fashion. They didn't tell us what it is, but suppose they could. So the red and the blue, of course, is this one. And they want to go this way, that would be the path forward towards sustainability. This is one way to know. Then they found out that they forgot the societal part, social influence, so they decided to make it 3-dimensional instead of 2. They had the environmental and the cost, which is the economy, but they thought they need societal influence also. So they have now the ability to present product ideas, alternatives in this 3-dimensional form: environmental burden, societal influence, and cost. Here again, the data can be presented in such a way that you want to move towards the top corner of this cube. So, the question I raised before, are we moving towards sustainability or receding from it? So this is one way you can tell. How do the corporations do? Corporations usually, although BASF has a particular in-house ability and propensity to do these sort of detailed studies, but I don't know whether they do it for everything. But at least when they come to conferences, they are nice to present their best cases, of course. Other corporations don't do that sort of diligence. They look at some very important ideas. For instance, this is an example of Procter Gamble. Every corporation has corporate sustainability oaths and claims, of course. And here, the idea is how much progress are we making since 2007, 2002? And they have used only 4 indicators: energy usage, CO2 emissions, waste disposal, and water usage. And they show that since 2002, they have reduced all of these by about 50%, and not so much since 2007. Of course, there is a limit to how much you can do. And they also have a claim, a social responsibility claim, 250 million children to live, learn, and thrive. All of these claims, like they have, because of this their product of pure water, they have distributed for free throughout India and Africa. They have saved lives. All of these are basically for publicity purposes. So that social claim is basically bogus in my judgment. But people do that. If you use there is a saying that where you stand depends on where you sit. So if you sit in the corporate chair, your stand will depend on your position. If you are in an environmental activist group, what you stand will depend on what position you hold in that group. Okay, the third way of measuring is quantitatively. And this is something I had done about a decade ago. We have a way of integrating all of the indicators, and there could be an infinite number of them. N number of indicators can be used and consolidated in these fashions in the Euclidean distance. What it means in physical terms is, suppose you can imagine an n-dimensional space, and a particular point in that space for a product, for a process, for a country, for whatever, is determined by n number of different qualities, n number of different indicators or factors. And you make a qualitative judgment that we need to make improvements. So you have the numbers, so you want to make improvements. So you want to, from here you want to go here. And this particular distance would then be Euclidean distance in n dimensions. To do that, you need a base case, and this could be a synthetic base case, very easily constituted from the data itself. I don't want to go into details. This would be the typical Euclidean distance, and there is a geometric distance that also works. And we can test this idea using the same Fender case study, the German company I showed, aluminum, steel, PCPBT, and this 5 different formulations with 12 indicators. So I'm integrating all of these indicators and providing an aggregate to make comparisons to show we are maybe making progress or not. So this is the number. This particular methodology has the ability to determine not only which one is better, which one is worse, to what extent one is better from another, but also can tell which indicators are essentially unimportant. So by doing this analysis, we found out that of the 12 indicators, only 6 need to be considered. And I present data here for all of these using both 12 and 66, and you could see that the decision is unchanged, that there is no point in spending money collecting data on 6 more to come up with the same conclusion. That's the whole point. Place of modeling. Modeling is for prediction, but there are 2 kinds of predictions one could do based on retrospective data. Retrospective modeling means you already have the data and you are making a model using the data to make predictions that are proximate to what you have. Prospective modeling, on the other hand, is very useful in decision making, but you don't have the data. For instance, you are designing a new process. You couldn't possibly have data on the new process. You have the data on an old process. So suppose you could model the old process and through some machinations come to describe the new process in terms of modeling and generate data, and through all kinds of process modeling techniques, come to predicting the behavior of this particular process. That would be prospective modeling. So these are very important things to do. I don't want to go into the process modeling in details because this is typical engineering, and if you are in engineering, you already know what those techniques are: heat integration, process integration, mass integration, process modeling, process optimization. All of those techniques, there are all kinds of softwares available in the marketplace to do that. But in closing, I want to make some key perspectives on global sustainability, because this is where discussions take place, especially politically. And political discussions are very powerful, and therefore one needs to have a handle on how to assess the claims that are made for global sustainability. I'm assuming that I can have a few more minutes. Is that true? Okay. KPMG International did a study in 2012 to determine the mega forces for sustainability. This is a management consulting company, and they collected data from all kinds of different companies and came up with these ideas. What are corporations thinking in terms of things that matter? Number one to them was climate change. Number two was energy and fuel. Three, materials, resources, scarcity, and four was water scarcity, and so on and so forth. I could independently give you my ideas on all four, but that's not necessary at this point. But keep in mind that corporations think climate change is the number one. But if you look at the survey of populations, I'm talking about the USA because that's what I'm familiar with, of the 16 different questions asked, problems pointed out, climate change is dead last or next to the last. So there is a disjoint here. So corporations are thinking the world is coming to an end, but people are oblivious, they don't give a damn. So this kind of disparity of perceptions is important to us to understand when we talk about global. This Richard Smalley, who won Nobel Prize for buckyballs, came up with ideas of factors that are important for sustainability. And he said that over the next 50 years, we'll face issues of energy, which of course he was right. Water, very true. Food, maybe. Environment, for sure. So, and the rest are essentially second tier possibilities. Just to keep in mind for sustainability that this is the way to look at, this is the way one academic looks at, elite academic, and the other way was the corporations look at. Now all of these ideas of climate change, energy issues boil down to how we manage carbon. At least at this stage, maybe 50 years from now, if there are windmills running everything and solar panels, this discussion will be completely different. But so far, we can talk about carbon management issues. Essentially what it means is that we have different sectors which use carbon in some fashion, and they all end up as emissions of some kind, either carbon dioxide or methane or some other gases. So they are all climate enforcing gases. And they're important in the discussions of the climate change. But you notice that the contributions vary. Depends on what the source is. it will report either to this particular area, this particular area, or that particular area. This energy is, of course, very important, most important factor in sustainability, and therefore deserves a special treatment. National Academy of Science in the US did that. And they, you cannot read it very well, and I cannot either. This wasn't this bad when I created the slide. But anyway, energy, the most important contributor, and this was one of the grand challenges that National Academy talked about. Here we are talking about 2005 to 2105, sorry. So what he was talking about is transition from carbon-based energy to non-carbon based energy. So the entire 100 years or close to 100 years were given by the National Academy of Science in the US for making transition away from carbon based energy. This is important because when we talk about alternative forms of energy, this point would be extremely important, because alternative means fossil neutral, or is it? But there is a carbon conundrum here. When we manage carbon, and all of these ideas of capturing CO2 and using it, reusing it in some fashion in a circular economy, bogus ideas, because carbon has 8 valences, -4 to -4 to +4, and all of these products and natural resources fall into this area. Methane, of course, has -4, and carbon dioxide has +4. So everyone wants to go down this hill into carbon dioxide. And in terms of free energy, this has the least free energy, so it doesn't want to climb this way. There are no, and I repeat, there are no chemical reactions outside of photosynthesis that is practical in converting carbon dioxide into anything that is more useful. Because this is a steep hill, this is an anti-entropic process. You cannot do it because the game is over here. Carbon dioxide is essentially the lowest free energy state. So what about photosynthesis? Photosynthesis is extremely inefficient process for converting CO2 into biomass. But sun is plentiful. Nobody cares about whether it's 2% efficient or 4% efficient. It's not more than that. But it is extremely useful, and that's why on aggregate, photosynthesis is the way to go if we want to do bio-based anything, and predictably people are doing that. Lastly, I would ask a few questions, since the point was sustainability. Let us talk about, is bioethanol cleaner or more sustainable? Is large-scale use of wind energy for power clean or sustainable? Is solar thermal or photovoltaic power clean? Are electric cars clean or sustainable? Is hydrogen economy clean, desirable, or sustainable? Is it clean to exploit almost the entire periodic table for high-tech devices? Is it a clean and sustainable practice to use bottled water for drinking? If a corporation claims sustainability based on CO2 reduction, is the claim valid? All of these are ideas that you are familiar with. And the answer is, in one word, perhaps, because it all depends. Depends on what the system is, how the system was configured, what the objective of the assessor was, what indicators were used, and how the measurements were made, and all of those. So therefore, if someone using one or two indicators, claim sustainability, just like those blind fellows who are describing the elephant, they would not be automatically wrong, they will be partially right. Whether they can be totally wrong, we need more data to opine on. Thank you very much for your attention.
Now it's fine? Yeah, thank you, Dr. Sikdar, for the nice presentation. And Dr. Sikdar, with his vast experience, he has, in a very nice, simple language, in a storytelling manner, he has explained various complex issues with sustainability. So before much wastage of time, let us have one or two questions from the audience. Yes, please.
Sir, I congratulate you for presenting the issue in such a analytical manner.
Thank you.
It will take, of course, time to understand that. But certain broad point that came to my mind is that when we say that USA is developed, that means production and consumption, there is an equilibrium in that. Then why sustainability issue comes to them? They are already developed. Are they thinking that that particular stage is declining? That is number one point. Number 2 point, dematerialization to metals, as you have said, aluminium, steel and all that. Do they want to reduce the production, metal productions or like that, so that they can take care of emission and say effluent, etc., to come down to a stage that they do not, that sustainability is maintained, that their developed stage is not declining?
It is, I may not have mentioned, maybe I did. Relative sustainability is what we are talking about, because we don't know what sustainable is, because any definition will serve the purpose. Sustainability, if you look up the dictionary, it means maintaining or keeping the present condition intact. This is sustainable. If you are poor, you are sustainably poor, but that's not acceptable definition, right? So we invoke idea of relative sustainability. That's why I said, are we making progress or are we not making progress? To do that, we need some measures. And in terms of these specific questions you asked, dematerialization, I cannot quite focus on aluminum or steel because I don't have the data on those things myself. Nor do I think I could make a case based on one particular data. Aggregate data are available. We know from fact that those aggregate numbers are going down while the GDP is going up. This is the definition of dematerialization. So our GDP has been going up. In fact, US is doing very well right now in terms of growth. Now 3% growth over a $14 trillion economy is a huge number. So we are making that progress. However, the other question was whether we are, no, I think I'm just implying that you were thinking that are we going to stop making production of something or other. I don't know. These are questions not made by a particular person or the government, because there are millions of entrepreneurs who are available in the marketplace thinking up ideas, and in the aggregate we see a picture appearing, but the actors are very many and we don't control them. Nobody told us that we needed a cell phone, for instance. Steve Jobs had the idea of an iPhone. Nobody said that we need all these features in the iPhone. But once you create it, and it boomed into huge business with so many tentacles, it's unbelievable. So this is how wealth is created, and that has been happening while, as I obliquely mentioned, the periodic table. If I could show you the periodic table, you'd see that in the 80s, for instance, maybe 13 or 15 elements from the periodic table were used in industry. Now it is over 60. So we have gone into the transuranic, not transuranic, we have gone into these rare earths. Rare earths are very expensive and very damaging to the environment when you are recovering them. Lithium, then praseodymium, gadolinium, all of these things. They are needed in making devices in electronics as well as in windmills, for instance. Therefore, those things are happening and we are not looking at. They have their consequences and we have to deal with them. But meanwhile, we are generating wealth which would be able to make us solve these problems we are creating because of this environmental goodness curve.
Okay.
Sorry for a long discussion.
Okay, we think we can have one more question and further
There was
discussion
one
may
here.
go on.
There
Yeah.
was one here.
Yes, yes, please. And further discussion may continue during lunch hour and later on.
As I understand, these two words, this sustainability and development. Okay, development means more energy consumption. Okay, so if we go on developing, then energy consumption will increase. And
Not necessarily. That's the part we were trying to emphasize on, that energy consumption per capita doesn't have to go up when the GDP goes up.
then we have to define development in a very precise manner.
Well, the global practice is to use the word GDP, or acronym GDP, gross domestic product, in some fashion, per capita GDP. So that's what I'm using, because still, and there are other measures proposed, human development, etc. United Nations uses that, but this is not widespread. No company uses that. No country uses those numbers.
No, we generally mean development means economic development or physical development. So then in that case, the energy is bound to increase around development. Because you have to
My thesis is, though,
well, unless it is something like called mental development, then you don't need energy. That's true. Is it that way?
I'm yet to know. So any development requires the economic development. I'm yet to know economic development happening because of physical development or mental development, etc. You have to have economic activities creating wealth, so you are able to do things, even your workout, exercise, and yoga, and meditation, etc. All of those require energy. So I don't buy the fact that, in fact, my thesis was dematerialization is happening, and this is a proof that GDP doesn't have to. When GDP goes up, resources use doesn't have to go up as well. Thank you.